This is Team Rocket. We are a group of manufacturing engineers and have been tasked with redesigning this bracket. The only specifications given to us have been the 3 overall part dimensions and to accommodate ease of manufacturing for a sheet metal worker. After brainstorming, we have decided to make the following design changes.
First change we have made is cutting a relief notch where the bend comes to a corner. The relief notch is cut to minimize fracture and wrinkling in the corner. Second improvement and change we have made is removing the slots that are on the sides. And we remove these to avoid distortion when the part is bent and improve overall strength. And the third change we have made is to move the holes inward and spread them out. This is to lower the risk of distortion when bending and also to improve the strength of the bracket.
Based off the overall size of the bracket, we are assuming that this bracket will experience substantially large loads. Given this, we have decided to use .063 mild steel due to its malleability and strength. Concerning the features of our bracket, we have followed 3 main guidelines. These include making holes 20% larger than the material thickness, ensuring holes are separated by considerably more than 2 times the metal thickness, and spacing elongated indentation or slots more than 4 times the steel thickness.
Based off of these considerations, we've calculated that the radius of the material along the bend must be 0.09 inches, and we also accounted for the stress due to bending in alternate directions that's with parallel to the rolling direction and perpendicular, and so we accounted for a little bit more, and so we determined that the final bend radius would be about 1/10 of an inch. Putting all these factors into play, we decided among these 5 processes for producing our changed bracket design. First, we will pierce the alignment holes. Then we will shear the rough shape of the product into the triangular shape from the original plate of steel. Then we will form the indentation in the middle of it. We will bend the edges down, and then after all of that is said and done, we come up with this finished product. And we chose not to anneal because
we chose not to anneal to cut down on costs and to cut down on time, because the steel we have chosen is already ductile enough, so we don't need to make it more ductile.